Hi guys, yesterday we talked about adaptation and we talked also about overtraining. We are going to continue with the short version of conditional abilities. So what is conditional ability? We think that strength, endurance and speed, these abilities belong to conditional abilities. They provide a basis for skills, technique and tactic. Without a certain level of strength, endurance and speed, naturally you cannot perform the technique properly and you cannot really develop normal or optimal tactic to win. So these abilities are extremely important. So let's see, first of all, whether these abilities are complex or not. Naturally, these abilities are very complex. There is a lot of overlap between strength, endurance and speed, but because of didactic reason, we separate them. So first of all, let's see what are the influencing factors of strength, endurance and speed. In case of strength, probably we can say the skeletal muscle, hormonal system and central nervous systems are very importantly limiting the development of strength. How about endurance? In case of endurance, cardiovascular system, naturally heart and circulation, skeletal muscle and psychology. The way how can you cope with the stress, with the monotonity is extremely important. And in case of speed, we would also say the skeletal muscle is important. Genetics may be the most important here if we compare to endurance and speed, and the central nervous system also plays a very important role. So as you can see, all of these abilities, there is one common, which is called skeletal muscle. So first, I'm going to talk about skeletal muscle, very short review. And I'm jumping and maybe come back later. So let's see, when we talk about skeletal muscle, we can see the muscle belly here, which is actually joined to tendon. We have a point here called the muscle tendon junction. This is the weakest point of this system, and the tendons are attached to bone. So this system, this part of the system generates force. This transmits force to the bone, and this is how we can have motion and movement. And then if we break down the muscle to smaller unit, we have a muscle fibers which covered by connective tissue. This could be extremely important for the protection of muscle fiber. Also, it is important because naturally it separates muscle fibers, and if we can get the smallest unit is called sarcomere. What you can see here, it's also, we can say this is a muscle cell which is separated by Z lines. You can see many Z lines, very beautifully structured. You can see here and the dissection area, and we have many proteins naturally in the sarcomere, but I just want to point out some very important contractile proteins. We have a protein which is anchored to Z line. This is called actin, the thin filament. You can have a thick filament here in the middle. This is called myosin. Both of them were discovered by the very famous Nobel laureate Hungarian scientist Albert Szent-Györgyi. And we also have troponin. Later on I'm going to talk to you about that. And then we have nebulin, titin, and many other proteins, alpha-actinin, but these proteins are the most important one. Again, how it works. Again, the Z line here, actin and myosin. So this is here, the red one is myosin. You can see, we call this cross bridge. This is myosin heavy chain here. This is the blue one is actin, and the troponin is this blue and red one. But I have a better picture of that. This is what you can see. So here we get a myosin heavy chain, heavy head. This yellowish one, the actin, and this purple one is troponin. So this is how it works. So you can see a red ball is coming from here. It is attached to the troponin. It moves away the troponin from the base position, and this location of troponin opened a place where the myosin heavy chain can attach, and this is the cross bridge. And you can see in this process, then other ball is coming from here, this red ball. It represents ATP, and you see one part of the ATP will disappear. Then we will have an ADP, and we have an ATPase enzyme. This is the gray one. Every attachment of the myosin heavy chain here on the actin needs energy, needs ATP. And then you can see the red ball from the troponin, which is calcium, then has to go back to the sarcoplasmatic reticulum. This is what we cannot see here, to have a relaxation. So we have contraction when we get an attachment of the myosin heavy chain, and when there is no attachment, this is the relaxed state of the sarcomere. So I go back to the earlier slide. We can see here a neuron which is located in the spinal cord, innervates the muscle. We have a myelin sheath here. We have a jumping action potential coming, and if the action potential is strong enough, then we have depolarization of the membrane of the muscle, and as a result, calcium will release from the sarcoplasmatic reticulum. Then it gets into the troponin, we have seen, and the troponin is going to change the position, and myosin here can be attached to the actin. So this is how it works, and you can see in this process, number one, relaxed state, attachment, then the ATP will be ADP, the inorganic phosphate will release, and this state is called power stroke. So in this situation, the attachment between myosin and actin, which will be the strongest one. This is, in this situation, the actin or the myosin can pull each other. You can see the changes of the myosin heavy chain. The angles are changing here, showing the movement, and then the relaxation. So this process is working on in the muscle, and this is what results muscle movement. Here in the muscle, you can see this, I don't know exactly what color is this, let's see, reddish, brownish ovals. These are mitochondria, and in the skeletal muscle we have two kinds of mitochondria. We have a mitochondria which is located near the membrane called subsarcolemmal mitochondria, and we have a mitochondria located between the filaments, this intermyofibrillary mitochondria. So the function is the same. Mitochondria is producing the ATP, and the ATP is extremely important to keep the membrane potential. That's why we have mitochondria located here at the near the membrane, and of course we need ATP, a lot of ATP for the lot of mitochondria for the ATP production, which is used by muscle contraction. So let's see what are the factors which are limiting the force production of the skeletal muscle. So first of all, type of muscle contraction, and then type of motor units, number of motor units, synchronization of motor units, and size of the skeletal muscle. So let's see first what type of muscle contraction we have. We have three kinds. One is called concentric. If you see my fantastic biceps brachii, you can see. I was in the gym yesterday without effect. Anyway, so this is when I'm lifting my glasses. So this is concentric. And if I put an extra weight, my cell phone, and I cannot move because of the weight, that will be isometric. And if I put an extra weight, tissue, then it will be eccentric. So we have these three kinds of muscle contraction: concentric, isometric, and eccentric. If you see the maximal force, surprisingly, in case of concentric exercise, we can achieve the smallest maximal force, which can be increased if we switch to isometric contraction. And in case of eccentric contraction, when you put a lot of load, then your muscle can achieve bigger force, although the angle is getting bigger and bigger and bigger. And if you see the energy per Newton that you can achieve, surprisingly, concentric condition needs a lot of energy per Newton, a lot of more ATP than in case of isometric and eccentric exercise. So I'm going to tell you why this is happening. We got a fantastic researcher in the past called Archibald Hill. He wanted to be a sprinter, but he was not good enough. Then he switched to science, and he was very good at science. So he developed different kinds of theories. And for instance, he got a Nobel Prize too, because he was the first who described that muscle contraction results in heat production and so on. And in case of muscle, he made a system, and he said muscle is built up from three kinds of systems, such as contractile component. This is what you have seen, actin and myosin. This is the contraction, this is the contractile component. And we have serial elastic component, proteins like tubulin, but especially nebulin and titin. They have a special elasticity. And if the connective tissue, including tendons, also in the system, which also have a kind of elasticity, this is the paraelastic component. So I would say, of course, this is a simplification of the situation. In case of concentric exercise, you are just using contractile component because the load is pretty small compared to the force. And if in case of isometric situation, you are also using serial elastic components. And in case of eccentric exercise, you are using all of the three. Why it is important? It could be important when we talk about, let's see, injury prevention. If you want to train connective tissue, such as tendons, we have a lot of injury, let's see, in basketball and handball in case of knee injuries. You have to have exercise which really involves the connective tissue, which means you have to do eccentric exercise and isometric exercise in order to strengthen the connective tissue components of the muscle tendon system. So this graph is also from Archibald Hill. It says that if you have a small load, you can achieve very high speed. As you increase the loading, smaller punk, as you increase the loading, the speed of the contraction is decreasing, and then there is a load by which you cannot really move. So this will be isometric. You can see the speed is 0. And if you give an extra load, although the force is increasing, but you see the negative state now here, and it will be a kind of stretching here. So this is the so-called heel curve, very, very important, because it also can tell you what could be the best weight to work with and jump. So we talked about the type of muscle contraction which influences the maximal force generation of the skeletal muscle. And now we are jumping to the last one, as I mentioned to you, hypertrophy. So if you increase the size of the muscle, you increase the potentially you can increase the maximal force. Naturally, if you have a small muscle, like in case of a small finger, you can achieve smaller force with the bigger muscle, it's biceps brachii, or you can achieve even bigger force with the quadriceps femoris. So as you increase the size of the muscle, you can increase the maximal force. So one of the aim of the strength training could be to increase the size of the muscle. It is extremely important to decide what you would like to do. In some sport, increased muscle mass is very beneficial. In case of, let's say, American football, the size is extremely important. If you play water polo, and if you are just 40 kilo, you are always a submarine, you are always under the water. So it's not so nice. So in certain sports, when you have a body-body contact, handball as an example, again, you need a certain muscle mass. Of course, in other sports like high jump, you need a big force output, but you have to avoid big muscle mass. So therefore, we need completely different kind of strength training for a high jumper and for the American football player, as an example. So first, we are going to talk about how to build up muscle, and I try to explain why we have to use the certain intensity and duration. Yeah. So muscle mass is important. So what we know at the moment? We know at the moment that in order to increase the muscle mass, the muscle tension must be pretty big. Must be pretty big. So what does it mean? So muscle tension is dependent on the load. If you have to have a load which actually would result in, we believe, that this integration, what you can see here is a Z line here. So probably the damage, this integration, the Z band or Z line, could be extremely important. A kind of, I would say, micro damage would be important, because this micro damage would initiate repair process. We have different kind of sensors in the muscle. we have a so-called mechanoreceptor. So in order to activate this mechanoreceptor could be extremely important. And we also need naturally hormones such as IGF-1, insulin-like growth factor 1. We also need probably, if we can, this IGF-1 is associated with growth hormone, but if we can, it would be nice to use testosterone, which is also an anabolic hormone in this process. So according to current understanding, mechanoreceptors activation important, a kind of damage could be important, but what I cannot tell you in this slide, duration of the tension is also crucial. So at the beginning, maybe yesterday, we talked about the inverse relationship between intensity and duration. So if you have a high intensity, the duration is short. If you want to work with a long duration, you must decrease the intensity. So in case of muscle hypertrophy, what we know for sure, we need a certain intensity, I would say load size, to cause this mechanical stress to activate mechanoreceptors. And probably to activate the hormonal system. If it happens, then cellular signaling takes place. As a result, we will have increased protein synthesis. So what you can see here, again, this is mitochondria, and this yellow part actually called stem cells or satellite cells. So activation of satellite cells could be extremely crucial for the repair of the skeletal muscle and could be extremely important for the hypertrophy of the skeletal muscle. Skeletal muscle probably the only cell in our body which has more nuclei, not one multinucleated cell. So because if we have one nucleus actually is able to provide protein, because the proteins are coded at the DNA and certain genes are coded in certain regions of the DNA. So if you would like to increase the size of the muscle, getting bigger and bigger, it will be difficult for one nuclei to give activate so many genes which are responsible for the increased size. So therefore, as a result of muscle hypertrophy, usually muscles going to increase the number of nucleus due to the help of the satellite cells which are providing the nuclei to the muscle. So this is how the nuclei concentration is increasing in the skeletal muscle. So to our knowledge, the best loading to achieve this kind of cellular response is about 70–80% loading of the one repetition maximum, 70–80% of the maximum, and about 7 sets and 7 repetition per set. So this could be generally the best way to achieve muscle hypertrophy. If we further increase the intensity, then we must decrease the duration, and 1 or 2 repetition actually could not really achieve these cellular changes. So we have to have pretty high intensity and pretty high repetition, and we don't have to do the exercise in a rapid way, but very slowly would work, because the duration also important. So what you can see here, patient with a disease called Duchenne Syndrome. This patient is a genetical disease because these guys don't have the protein called dystrophin. This is what you can see. This is the protein called dystrophin, and unfortunately, due to the mutation, these patients don't have this muscle, this protein. And as you can see, there's a very important enzyme which is attached to dystrophin, which is called nitric oxide synthase. NO plays an extremely important and crucial role in muscle physiology because NO activates satellite cells, and the satellite cell proliferation is necessary to muscle hypertrophy. Of course, there are many other systems which are important for satellite cell activation. We have different kinds of growth hormones, IGF-1. We have some cytokines, like interleukin-6. So immune response is important, macrophages. The damage itself activates satellite cells. See testosterone and nitric oxide. Again, hormones here, and growth factor also here. So IGF-1. So you see, satellite cells activation is important. And some years ago, we did a study, and we have shown that SIRT1, this is a very important protein, plays an important role at the skeletal muscle hypertrophy. We published this work at the Journal of Physiology. We did a study. We removed the gastrocnemius muscle and the soleus muscle here from the rat muscle, and this actually resulted. Then the animals started to walk after the surgery, which means that the plantaris muscle, which remained there, had to keep all of the weight of the animals. So this process is called compensatory hypertrophy model, works very well. And what we found, we have a control group, the operated group. You can see very beautiful increase at the muscle size. And when we silenced nitric oxide by injecting L-name, you can see the hypertrophy was less pronounced, and we stimulated nitric oxide by arginine. We got again greater increase in the muscle mass. So without question, it seems that satellite cells through NO play a very important role. This is muscle fibers and ratio, and PAX7 actually represents the satellite cell number. This PAX7 is found in satellite cells, so you can see if you knock out NO by L-name, less satellite cells were present. SIRT1 protein increased, and finally we got this model. SIRT1 activate ACT pathway, mTOR, and protein synthesis. Okay, so this is the process actually for how we make myotubes, which is almost no muscle, from stem cells. Stem cells are not differentiated cells. In order to differentiation, they need a kind of support, which is given by MyoD and MIF5, and then stem cells form a myoblast. Here you can see an extensive proliferation, and this proliferation actually controlled by the protein called myostatin, blocks the proliferation. Look at this. This guy seems to go to the gym day by day, but this is another case. What happened with this cow? These guys have a kind of very special mutation. Myostatin is absent in this cow's muscle, so there is no limit of proliferation, no control of proliferation. And as a result, we have an increased muscle mass, and naturally we will have a fantastic steak. So this, guys, could be very important. And this was a result of a kind of genetical mutation. So this is from our lab, very powerful. Goes to the gym 5 times a day, and you see, extremely big muscles. Today is 1st of April, probably. Yeah. So what we have here, normal mouse and the transgenic mouse. Yeah, that seems to be fat. But let's take off the clothes. What happens? This is again the normal, the control or white type of animal, and this is genetically modified transgenic animal. Why it is so important? Because if you know what are the factors which are controlling the mass of the muscle, the size of the muscle, if you know what are the important factors, then you can modify them. First, this is a genetical modification. Okay, you can play with the genes. You can do it on animals, fine. But the next step is pharmacy. So then you have to find this kind of pharmacological agent which stimulates or blocks your targeted proteins. And then, not surprisingly, now we have some kind of blocker of myostatin on the market. If you can block myostatin, you can increase muscle mass. Why it is important? Of course, it could be important at sport. But it could be also important for your grandmother and grandfather, because they are losing 40% of their muscle mass by the age of 70. So, and of course, they also losing mobility. In order to prevent this, muscle mass is extremely important. So if you can increase the muscle mass pharmacologically and naturally together with exercise, that could be extremely important to prevent sarcopenia, which is age-related decline in muscle mass, to prevent diabetes too, or to go to the Mars. You know, now we have a technology to fly over there. But the problem is our muscle and bone system cannot really endure this long flight, because even though we can reach the Mars, we cannot get out of the spaceship because our muscles will be very weak due to the long flight in anti-gravity condition. So this could be extremely important to find a way to increase the muscle mass during the space flight, and could be just one possibility. So everything is complex. Everything is extremely complex. Here you can see our slide, what we created and where we have shown how important is SIRT1 in muscle hypertrophy and how many signaling pathways are happening which results in myogenesis and increased muscle mass. Extremely important. First of all, if you want to have increased muscle mass, you have to increase synthesis, and you have to block the degradation. You have to block catabolism, and you have to increase anabolic process. And this is what this protein SIRT1 is doing according to our study, and this is how the muscle mass is controlled. So naturally in this process we need hormones. No question, hormones plays a very important role at strength training. See the difference between male and female. See the strength difference between kids and adults or aged. No question, this is somehow associated with hormones. As I showed you earlier, this is the skin of the skeletal muscle, and we have receptors for testosterone, we have receptors for IGF-1, we have receptors for methanoid growth factor, and so on. And these hormones activating cellular processes in the cell, activating ACT protein, mTOR, and then result in increased protein synthesis. So these are the main proteins in signaling proteins in the muscle cells which need activation in order to enhance protein synthesis. And we have satellite cells here. Okay, so what happens? As I told you at the beginning, I try to convince you that the intensity of the exercise is the most crucial part of the exercise. Intensity and intensity and intensity. So what I'm going to tell you now, that the intensity of the exercise affects the production of growth hormone. So if you do exercise with lower load than 50% of the maximum, during exercise, the growth hormone concentration actually tends to decrease and even stay at low level after 3-4 hours after the exercise, even the resting period. As I told you, adaptation many times generally takes place at the resting period. So you got a loading and then you have a rest. During the rest, you have a compensation and overcompensation. What happens if you have a high intensity exercise, over 70% of the maximum? No increase at growth hormone concentration during the exercise load, but then there is an increase at the resting period. See? At the resting period, when the adaptive response takes place. So growth hormone actually helps us to enhance protein synthesis if we do high intensity work. So this is extremely important. How about testosterone? The behavior of testosterone is quite different. If you have low intensity exercise, again, testosterone concentration during the exercise goes down and stay low. Actually, you know what? Let's say marathon runners and even triathloners, when they are doing exercise with low intensity and long duration, the testosterone level is very much suppressed. And actually there are some data which suggest that even the fertility is a bit suppressed compared to those who are doing high intensity exercise. Isn't it interesting? So the exercise intensity itself affects the testosterone concentration. So, but in case of testosterone, which behaves differently than growth hormone, during exercise, the testosterone concentration is increasing if you use high load, higher than 70% of the maximum. Testosterone increasing, but not forever, for about 30 minutes, and then testosterone going to decline, even below the base level. So to prevent this, actually, you can separate the training session into small parts. You have a high intensity part for 30 minutes, and then you can do something like stretching or whatever, some other kind of exercise, and then after 30 minutes, stretching or other kind of exercise, you can again enjoy the enhanced production of testosterone if you do high intensity work. So this was discovered and applied by a very famous Bulgarian weightlifting coach called Abagiev. It's called, so he was extremely smart and he switched the training according to the behavior of the body. I think it was super, very nice. Okay. So we talked about muscle size. We agreed, I think he didn't say no, we agreed that you have to have about 70% of your maximum, 7-8 set repetition in order to increase the size of the muscle. But look at this guy. Almost no muscle, but he was extremely powerful. By one punch, he could break maybe 10 bricks. So he was extremely powerful. How is it possible? Very different way than Arnold Schwarzenegger. Both of them were very successful and, of course, very powerful, but completely different pathway. So in some sport, we have to think about build up explosive strengths, maximal strengths, without big increase in muscle mass. What is the secret? How to do that? So this depends on this kind of training, which is called neuromuscular training. Is depending on the activation of fiber types. We have two kinds of skeletal muscle. Three. We switch to motor units. So we have three kinds of motor units in the skeletal muscle, three kinds of motor units in humans, such as small, medium size, and large. These neurons are located in the spinal cord and they innervate certain number of muscle fibers. And as you can see, the axon is a bit different, bigger, and let's see the behavior of the small motor units. This is the force production. Not so much. This is the medium size force production. Much bigger. And this is a huge force output here at the large. Large is called fast. The fast motor units, or I would say white fibers, fast twitch fibers here are very, very powerful. But the resistance to fatigue is very poor. Look at, after 1 minute, no force production. Here at the medium size, not a big decrease at the, as a result of fatigue. After 6 minutes, you can have almost the same force as after the second minute. But look at the slow twitch fibers. After 1 hour, the same amount of force. So I would say I have to talk to the Suzuki and the Ferrari and get some money from them. So anyway, because I would say this is a Suzuki, small motor units, which means with a small amount of gasoline, it can run a lot. But the force output, the horsepower is not so high. Here we get a Ferrari, let's say 500, 600 horsepower, but you have to visit the gasoline station every 200 meters to get some fuel. Completely different. So I would say that fast fibers are, in case of evolutionary term, fast fibers are for fight and to escape, and slow twitch fibers are for daily activities. So these are very, very economical fibers. They are not really producing lactic acid, oxidative fibers, and these are glycolytic fibers producing a lot of lactic acid. And please do not forget the medium, the mixed fibers, because they have both characteristics. So maybe these medium fibers are very, very beneficial and useful at many sports. So what you can see here is the differences between fast fibers and slow fibers. Time to the maximum contraction, you see the differences. Myoglobin concentration, dominant pathway, myosin ATPase activity, size of the motor neuron. Where is capillarization important? Mitochondrial number, I cannot see mitochondria. But naturally, slow fibers contain much more mitochondria than fast fibers. Glycogen content also different. Now here, myoglobin and mitochondrial density is very different. So this is a size principle. What does it mean? It means that we always use first slow twitch fibers. We use slow twitch fibers first because they are very economical. So when we are standing, walking, running, usually we are using slow twitch fibers. And we can just activate fast twitch fibers when we do high intensity exercise such as sprint or jump. This is very important. So if you want to be Bruce Lee, you have to activate fast twitch fibers. How to do that? The problem is that fast twitch fibers have higher threshold. What does it mean? It means that you have to do high intensity exercise. What high intensity exercise means? Either means maximal speed like this, or it means maximal load. So both could be useful. Either using maximal load or maximal speed, depending on the type of the sport. Naturally, if you are involved at, let's see, the javelin throwing, when you have to throw 800 grams of javelin, you have to focus on speed more than if you are a hammer thrower, because hammer is 7.25 kilos, so there is a huge difference between the weight of the hammer and javelin. So if you are a hammer thrower, you have to focus on more on maximal strength, and if you are a javelin thrower, you probably have to focus on more on maximal speed, as an example. Okay. This is the relationship between, this is the so-called force pyramid. If you increase the intensity, naturally you have to decrease the duration. Here in this zone, which is called maximal strength, here explosive strength, and over lower intensity than 50% is strength and endurance. So depending on what kind of training you would like to do, you have to choose different intensity. Naturally, the hormonal system will respond to the intensity. Naturally, the adaptive response is dependent on the intensity. Here you can see the summary of different kind of strength training, always given the type of muscle contraction, concentric or eccentric, the intensity, repetition, set number, rest, and you can see the effect. As an example, exercise with small load improves strength and endurance. The secretion of anabolic hormones is close to zero in case of small load. To enhance muscle capillarization, it is nice. No hypertrophy, no increase in maximal strength. On the other hand, if you use 80% of the load, exercise with high intensity increases hypertrophy and maximal strength. It could increase the content of connective tissue as well. So we have different kind of methods selected, gradually increasing load, isometric method. You can see isometric exercise is completely forgotten. It was a big fashion at the 50s to increase muscle mass, very easy to increase muscle mass, but because there is no movement, it's almost completely forgotten, but it has some good effects. So as a supplementary exercise, I would really recommend doing isometric exercise. So we have isokinetic training when the speed is constant. We have intermediate training, a mixture of isometric and eccentric, isometric and concentric exercise. We have training with random load, submaximal load or maximum load. We have reactive explosive training, extremely important. It's also called plyometric exercise, eccentric exercise. Eccentric part of the exercise is very pronounced here. So you have to stretch the muscle before the contraction so you can have a very high speed. You have to be careful because you have a greater risk of injury here. You need assistance, and you have to use exercise in which you are familiar with. We have a quick release method, very nice method, like this. We have an isometric contraction, and then we have a concentric activation movement. Very nice. You can use electric stimulation, or you can use circuit training. So there are many methods to improve the strength of the muscle. Depending on the aim, what you select, you have to choose the intensity, and then you have to use the type of exercise which satisfies probably your aims. So this is the end of this part. Thank you very much.